A line has equation y equals 3x plus k, and a curve, which is a quadratic, has equation y equals x squared plus kx plus 6. K is a constant. We need to find the set of values of k for which the line and the curve has two distinct points of intersection. If the line intersects the curve, there is a common x and y coordinates. So we equate the equation of the line and the equation of the curve. X squared plus kx plus 6 equals 3x plus k. Now move everything over to the left. X squared plus kx. When you move 3x, we have negative 3x plus 6 minus k equals 0. It's better if you group these two together. So these two, it can be factored to be k minus 3x. And then that is the last term here, 6 minus k equals 0. This is a quadratic where a is 1, b is k minus 3, and c is 6 minus k. We need to find the values of k where the line and the curve have two distinct points of intersection. For this equation to have two distinct points of intersection, you must have two unique solutions that occurs when the discriminant b squared minus 4ac is greater than 0. Then we have two solutions which corresponds to two distinct points of intersection. b is k minus 3. The square of k minus 3 minus 4, a is 1. C is 6 minus k. This is greater than 0. We need to expand and simplify. So expanding the square of k minus 3, that would be k squared minus 6k plus 9 minus 4, and then we have 6 minus k. So we need to expand this further. That is negative 24 plus 4k greater than 0. We collect like terms, k squared, negative 6 squared, negative 6k plus 4k, that is negative 2k. And then 9 minus 24, we have minus 15. This is a quadratic or a trinomial that can be factored to k minus 5 and k plus 3. So we factor this, and now we need to solve the inequality that k minus 5 and k plus 3 is greater than 0. In order to do that, we find the zeros of this first. K minus 5, set this to 0. You have k equals 5, and set k plus 3 to 0, so that k is negative 3. We draw a sign diagram using these two values of k. We have negative 3 and 5. Let's look at the first linear factor, k minus 5. K minus 5, you can actually use a test value. So you can use the test value less than minus 3. You can use the test value of negative 4. On this interval, you can use the test value of 0, and you can use the test value of 6. So when you replace negative 4 into k, you sub it into k, then you have a negative value, so you have a negative sign. When you sub 0 into k, you have negative, and when you sub 6 into k, you have positive. And we also have k plus 3, and you could do the same here. That is a positive, positive, and a negative. Look at the product of sign. Two negatives is a positive, positive, negative is a negative, and that is a positive. we need to solve the inequality greater than 0. So we look at the positive sign. The positive intervals are k less than -3, and we also have k greater than 5.